Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show, thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, for those new to the show, my name is Shawn from Insights in Automation, and each week I invite a new vendor to come on the show to talk to us about their products and technologies. And during their presentation, I'll play the role of the audience. I'll ask questions I think you guys might have, as well as questions I have. And given that a quarter of our audience listens to the show but doesn't watch it, just listens to it, I'll try to call attention to any details in the visuals that I think you listen only people may want to know about. Now, with that said, I want to welcome Nick back to the show. We got a very exciting product to talk about. But Nick, because some of the people may not have caught your last appearance, could you do like a quick little intro on who you are?
Yeah, happy to do that, Shawn, and thanks for having me back here again. So I am Nick Rosner, Senior Offer Manager for the Altivar Machinery and Building Solutions with Schneider Electric. And I am the launch manager for the Altivar 320 solar products. And that's what we're here to talk about, this new innovative solution for the industry that grabs power directly from a solar cell onto the DC bus of a VFD and make it into useful power for a motor, pump, compressor, fan.
Yeah, there are some great videos Nick sent over to me, and I was just watching them. I'm like, wow, this is really cool. So, Nick, without further ado, let me turn it back to you and let's jump in.
Yeah, thanks again. So let's go through this. I'm very excited to talk about this. And it's by the way, Shawn, a pre-launch. So a lot of this information is actually not even available online yet, but can certainly tell people how to get the information from your customers. So many of these links that I have currently, the majority are actually internal. So the only way to access these would be either through a Schneider salesperson or one of our Schneider distributors or channel partners. So my recommendation for those that want to be involved in the pre-launch and some of our development to reach out to your Schneider distributor.
Now, because it's a pre-launch, does that mean some of the things might change a little bit between now and the formal launch?
I don't anticipate that, Shawn. We really have a lot of the things set and established, so it's more of the formalities of getting the
Ah, okay.
product commercialized in the US in terms of our internal systems. But as far as certifications, features, stock, and manuals, those are all up and running.
Oh,
So,
nice, nice.
mhm. And I mean, going back to this exciting launch, there's many ways we can apply this product. So obviously, the first thing that may come to mind is solar pumps, solar skids in farming. So for some of these remote applications, that's the most traditional way of applying this product. But there's just so many other things we can do with this. Portable compressor skids, HVAC, high velocity, low speed fans, and it has an adjustable source, switchable source, I should say, between the DC bus and the AC power. So you can actually have both connected and have them switch over. And we'll go
Oh,
over through
wow.
that on how that looks like. So that is one of the very cool features and advantages that we have here to showcase. And beyond that, the manual switchover that we have with that, some of the very cool integrated pump functions that we have on this very small ATV320 VFD. So for those familiar with the Schneider ATV320 product, it's the same form factor as our compact, and we can go through the low horsepower rangers which we have available. Since this is a very cool offer going into the DC bus of a VFD, we essentially have three products where you can do that. What we're here to talk about is the product that's specifically for solar applications. So if you think about the irrigation, golf courses, fountains, pools, residential, there's just countless of applications that we can think of or we can apply this in our markets. We'll go through some of the details as to why we came out with this launch and the reasoning behind it and the growth and traditional aspects of it. But if we want to get creative, talking about our decarbonization goals, our energy savings and off-grid, it's just a very cool technology, something very unique. We have all the global certifications, UL on the DC bus portion, UL on the main power. So for those that want to create UL panels across the board, obviously global standards to go with that. This is just a great solution. So Before we jump into the technical product, any questions that may come up before we go into the core of the horsepower, the voltage, and the features, Shawn, that you can think of?
No, I just thinking that, and this is, I haven't seen any of the material yet. And that's one of my requirements when somebody comes on, because I want to see it for the first time, like the audience. And I'm just thinking this really simplifies those standalone systems in the middle of nowhere that, there's no power that's running to it, right? So, I mean, think of what you would have to do with a solar panel prior to this is you would have to go to a battery typically, right? And you know what? What if you only need the pump to go when the sun is out, right? Why do you have to have all the cost and, batteries don't last forever and all these other things? If we could take that solar power and put it right to the DC bus of the VFD, then when the sun's out, we can be pumping, and then when the sun goes away, we can just stop. We don't need all that other, not to say that that stuff isn't good, in some applications it'll be needed, right? But it can really bring down the simplest of the simple applications: solar panel, VFD, pumper motor. And I just love the simplicity of that for certain applications. Again, granted, it's not for everyone. And so let me just throw it back to you. Those are kind of my initial thoughts.
And that's just a great point, Sean. I'm very happy that you brought that up because the other day we were with our mining team and they asked us, they have a solar farm and they have a solar inverter. Well, guess what? We can apply this a couple of different ways. With a VFD, you don't really need the solar inverter because you're using the inverter, the VFD, to make it into useful power. So number one, yeah, just to be overly helpful with how we're trying to apply this, and there's no need for dual inverters. But you can use a battery backup or maybe a generator backup as a backup. As you mentioned, maybe during the night, if you want to pump, switch it back to that battery or generator, and during the day, use the solar power. So that's those are all valid and unique applications here. So going back to the mining, remote applications, solar panels, the end user may spend a couple hundreds of thousands just to get power into a remote situation. We can start looking into alternative sources of how to be able to power your equipment. So that's just a very compelling story behind that. But without further ado, Shawn, let's jump into some of the technical features and some of the product details that we have here. Going back to the core product, as I mentioned earlier, initially the intent is in the picture you see here, the Altivar 312 Solar. So Schneider did have a solar VFD in the past that we used for farming. It was in low horsepower ranges. And the 320 Solar is the upgrade of the 312 Solar that we used to have before. And we just added so many more features. The multi-point power tracking, you used to have to manually program that. Ours is just automatically programmed into the VFD, easily to turn on and off during the switchover periods of main power or solar power. So we've just tremendously upgraded this and even increased the range there. So you see here this assembly on a NEMA 3R panel. Obviously all the switches, relays. We have all the documentation here to help our panel builders, integrators, skids and OEMs and panel people to put this together. As I mentioned before, there's the DC bus directly onto the VFD. And then we can either do a filling a tank, going straight to irrigation. This was the previous technology that we had here, just to be overly clear and helpful on what that used to look like. Now, what is the next generation product? What's the difference here? Hopefully you all recognize this. This is the Altivar Machine 320, but it now has been built for Altivar Solar 320. So you'll see that the dial here looks like a sun. You'll see the QR code to download the data at the front of the VFD. And we have all the ranges here available for that. So it's going to be on the compact form factor specifically. It's going to go from single phase to 8230, three phase to 8230, and 3-phase 480 volts up to 20 horsepower. And the DC voltage ranges are right here. This is kind of key to know the DC voltage ranges because depending on, as we will see in the next few slides, what that looks like, that's really going to dictate the current, maximum current that we can put into the motor. We have our 6 digital IOs, 3 analog input, 1 digital output. So our traditional outputs that we have with our Altivar machine are the same IOs that we have with the Altivar Solar 320. We can do synchronous and asynchronous motors, so induction and PM. It's IP20, mainly for panel build applications, and has our conductive emissions, so our EMC standards as well, and protection. Communication is here as well. The Modbus and CANopen are the standard, and our optional communication cards are here as well. Another cool thing that we have on the Altivar 320 Solar is that we also have integration into the Schneider EcoStruxure platform for remote monitoring. So for those interested in that, we can also do a deep dive later on to that. The MPPT is a very important thing to know anytime we're dealing with solar technology, the multi-point power tracking. And that is, in the lingo of solar, the specific algorithm that graphs that DC bus and creates it into useful power, because obviously there's going to be some ranges, some switching, some irradiation, clouds, different types of conditions that will change that DC bus. So that feature is really important to grab that changing DC bus and create useful power out into a pump, motor, fan, compressor. Very important here. I touched a little bit on the dual supply changeover. This is another very cool feature. So it can switch from solar to grid and vice versa through a manual switch, and we can go through the circuitry in a bit on how that looks like. You touched on battery and maybe solar generators, Shawn. Those are also things that we can switch over. The important thing is if we're going to a grid or a main power, has to be on for the switching to work, because that's what's powering the relays to do that.
Okay.
It does have a tank liquid probe function, so it'll fill up a tank. The pump functions are here as well. Has a pump curve, anti-jam, dry monitoring, flow estimation, pulse counter, and volume counter. So for those that need to measure the volume per reset per day, you can use a pulse counter, which is a device that pulses and lets you know what the flow is. So it's very precise metering. Or you can use the flow estimation, which is a rough estimate if you are flowing water or not in a percentage error range. So that's the difference there. And you can use the volume counter to connect onto both and tag the number of times that you reset. So it could be half a year, a couple months, or daily. Going back to some of the cool functions that we have here, the ATV320 has the safety function. So for example, safe torque off, SS1, SLS. If you want to have some safety, somebody opens a panel or the machine and do a safety function, that's definitely available on the VFD through SoMove. And we also have, which is a very cool thing here, the ATV logic, which is our unique embedded PLC on the VFD that can create custom logic for specific applications or functions. So one of the things that we did here for the Altivar 320 Solar is we actually have a tested, proven function for a tank probe, if it's flowing, if it's not flowing, if there's a dry run through a linking diode. And as I mentioned before, EcoStruxure compatibility for remote monitoring. Here's some of our environmental protection features, up to 50C without derating, 60C with derating, and it has our altitude curves, derating as well for switching frequency, pollution degree, chemical class, and mechanical class protection on coating board, essentially.
And all the way down to -10C, which is important. And
let me go back here. Yes.
Yeah, and typically you'll find that if it's in an enclosure with electronics, it'll never get below that. And well, in most of America, I mean, you guys know where you need a heater. Heaters are very inexpensive, but that's important to know. I'm sorry, back to you.
Yeah, great point, Shawn. So obviously that's something we would design specifically in the panel for those cold climates. And going back to the frame sizes from what we have on single phase to 3-phase, these are our ranges. This is really more informational for those of our audience here to want to take a snapshot and make sure that it fits in their panel. Obviously in English, hoping to update to metric once we do our formal launch here.
And we're down a half horse all the way up to 20 horsepower is the range, if you guys didn't catch that earlier.
Good point there, yes. As far as accessories, important accessories as the other VFDs, the line and motor chokes. Now, a very unique, cool thing here. When we're grabbing our solar cell, tying into the DC bus, there's not a lot of harmonics there because we're actually using the power from the solar cells.
Hmm.
So that's a great way to avoid harmonics issues. Going back to the mining example, we, even though this is specifically for our 20 horsepower machine, we do have an application note for our Altivar 900 as well. They can go, I believe, up to 400 horsepower. So for some of these large mining applications, imagine not having to deal with the harmonics because you're tying directly into the DC bus. Harmonics happen at the input of the VFD, caused by the switching from AC to DC, and we're pretty much avoiding that by tying directly from the solar cell, not damaging the power from the grid. So just keep that in mind. But for those that do want the line motor chokes, that is available. The motor chokes are for the outputs. We touched on our COM cards. We do have the additional EMC filtering for a high speed, high hertz radio frequency filtering, conformity kits for the EMC, fan as accessories, mountain kits, and UL Type 1 kits to mount outside of machines. People here that are familiar with Schneider nomenclature, the ATV320C is the same model number. The range changes here, and the 412 would be the identification there, the difference between using a standard machine VFD versus a solar VFD. Now, this is important here, especially when sizing the solar cells. So there's a couple of ways we can do this. We've provided a solar sizer that can help with some general solar information, the cut sheet that you have to make sure we have the right number of rows, arrays to be able to power the pump or the machine. So this is the min and the max range for the solar cells. So when we're sizing for a pump fan motor, there's going to be two D ratings we're going to take into consideration. The D rating of the solar cell itself to make sure the DC bus powers within that range, and the D rating of the VFD, especially if it's outside. But for a non-D rate application, we're within these ranges. This is the max output that we have available from the VFD onto the FLA of the motor. So for those that are experienced here, very important that we size by FLA, and the FLA of the VFD has to be equal or higher than the motor, just as a friendly reminder. Traditional basic knowledge, it's just good to go through that.
Mm-hmm. Mm-hmm.
This goes up to 778 for the DC bus, 228, 403, and 404. So traditional DC bus ranges really works with any or most solar cells in the industry. Okay, going back to our story, why that we come up with this product, some of the cool things that we've talked about, and the energy savings that is still available here. It has our green premium sustainability certification, recyclable. So we do have obviously great things in our business to promote our green solutions, and everything from production to end of life of the product and recycling. This goes back also to some of the traditional applications that usually this comes up with, which is ag, irrigation, sprinklers, etc. I know we have a video here, Shawn. We can certainly have the audience go through it on their own time, but highly recommend that they go through this very cool video of the Altivar 320 Solar. It talks really about high level of what this is, main features, and some of the cool places where we can apply it. As I mentioned before, global certifications are here: European, UL, American, ROHS compliant. Very important to know that it has UL both on the DC bus and the main power. And why do we come up with a solar product? It's a very good question. So globally, 20% of the crops are irrigated by solar pumps. Obviously, this is very unique for other countries. And globally, just to be helpful here, this is a global launch, and that's also why we launched it. There's a 2.3 billion estimation of solar pumping that's going to grow to 5 billion in 2028. We want to be part of that growth. We want to be part of that sustainability story, and that's why we're also launching that product here in the US. So obviously there's some key segments here, India and in other countries where this is very, very important, especially with our diesel applications. I do think with our green initiatives that this can also be applied in the US market, very streamlined over here as well. So the goal here is to help desalinize some of these applications, take advantage of our solar arrays, and obviously compare that versus the square footage and availability to get power remotely. That really is the key here. Before we jump into the functions, specific things that we have on the VFD, Shawn, anything that comes up to your mind of the ATV320 Solar, some applications, why it's launched, or where else you think this could be applicated in the industry?
No, I really just think that, I keep coming back to only having one inverter. You're coming directly from the solar panel into the drive. So you're not inverting it first with a solar inverter, because every time you do that, you're losing some power, right? You're losing some efficiency. So this just makes it clean. You go right from the solar array to your VFD. You're not going through an inverter and then reconverting it later. And because every time you converge it, you lose a little bit, right? So that's really my thought here, and that's why I love these remote applications. And I'm sure there's more than I could think of, but these remote applications where you've always wanted to have a pump, but a full blown large battery system is very expensive, and then converting that back to run a pump is also expensive, and this is simplifying that panel. So that's what's running through my mind right now. Let me turn it back to you, Nick.
Okay, great. Thanks, Shawn. And we will go through those diagrams just to be helpful with the audience here on how to wire it directly from the solar cell as well. MPPT is key again for any solar application. This is automated into our VFD. In our previous 312 solar, you did have to enter some parameters to be able to tune it. We've really automated this with our VFD now. To show the audience an example of how this works, this very cool algorithm. So you see the solar cell here, the useful power, the voltage, and on the right you have the head and the flow, as well as the power and the flow curve. So let's run the graph here as to how this looks like with a changing temperature, irradiation, or shaded solar array for the audience. So you see the cloud here grabs onto the solar cell, and it does reduce the flow, follows the curve, and the power. So that's really what MPPT means.
For the audio audience here, as we're seeing as a cloud comes over the solar panel, the pump output is going down and proportional to the available power. So that's very cool. So you can even power if you don't have full sunlight. You can even pump, yeah.
And that's exactly right, Shawn. Yes. The other feature that we have here is the global maximum power point tracking. This one we do need to enter 2 parameters, but this is really to automate different clouding seasons, times, to make sure that even when shading or less sun for the next day versus the previous, there's an internal algorithm there that's going to make sure that our output power is going to maintain at the max of that shaded curve range. So this is the global maximum power point tracking. This is really for something that we want to use for more than just a daily use of the MPPT. It's seasonal use, shaded use, different seasons. It essentially has the algorithm embedded in there to change and attain maximum power during those switches and changes. This is what the global MPPT would look like. Partial shading versus the full shading. Just to zoom in, let's go into some of the cool features that we have here. The VFD itself can help you fill up a tank with a tank liquid probe function. So this is going to help you detect if the tank is full, to run or not run. If it's not full, check the status. And it also can help detect the probe error. So if you add some resistors there per our diagram, calibrate accordingly. If there's an error with a probe, can also alert there's an error with a probe, and we also need to adjust and fix that. So to make sure that we have the right filling there. This is very key to avoid having overflow or downtime and be able to properly fill the tank. I know there's quite a bit of details here on the manual. Highly recommend we go on the specifics there to go into the IOs, make sure that we have our non-inverter diode to make sure that any switches changes, there's no damage or power back to the solar cell. That's very important. So very key that when we're doing these features, applications, we follow the instructions for the user manual. They're specifically made for the long-term use of this application, and make sure that all the devices are protected accordingly. This is with more specifics here on the tank liquid probe assignment. So when the tank is empty, when there's a probe error, what the VFD and the pump should do. when the tank is full, low threshold, high threshold, all the configuration is there and available. The idea here, Shawn, is that we have this application as a standalone application. There's no need to add any additional hardware. You can do everything from the VFD and the ATV320 logic inside of the drive and be able to essentially program, configure, work, and do some of these cool application features for the ag and irrigation segment. One of the things that we do want to touch on is the dual supply changeover, how we can switch from the solar to the grid, and again, could be battery power or some other source of power. It looks like quite a bit of a diagram, but it's very important that we do follow the instructions that we have here in the diagram use of it, because what we are trying to do here is the VFD itself will tell you when you can switch over from solar back to main power. You have all the relay logic here from connecting onto the DC bus itself, and then the solar main power as well through the relays connecting back to the grid. Essentially what this does is if you try to do a manual switch when the VFD is not ready, as long as you follow the instructions that we have here, you will not be able to go back into main or solar power unless the VFD gives you the green light or allows you to do the switching. So it's a manual switchover that we have available. A couple of important things, as I mentioned before, the non-reversing diode and specific follow the instructions on the installation manual to make sure that we have the right use of this application.
Do you have a pre-canned assembly that has that in that? In other words, drives and the enclosure with the switchover all wired up?
Yes, yes, we're working on that actually, Shawn, to make sure that we have specifically a bill of materials, the components, make sure that the panel assembly has the correct. Yes, that is something that we will be adding to our launch. This is something that we're working on. Yes. There's obviously more things that we can do here. We can do some of the Boolean, the reference switching, work on preset speeds. So there's a lot of very cool recommendations that we have on our installation manual and how to program through the logic, through the VFD parameters, and how to be able to switch between references. If we're using a PID loop, all that will be available through the VFD. And obviously, anytime when we go through the DC bus solar, activate the MPPT, and be able to switch into, for example, main and PID and other sources or programming within the VFD itself. So we can get extremely sophisticated, or we can keep the application as simple as possible. Back to your point, we can create a specific bill of materials for those that are interested in being part of the pre-launch and the development of this very cool technology. This usually helps quite a bit to understand what the VFD is doing or how it's going to operate between essentially a switching of main power. The Q is the flow. These are our flow sources from solar to grid. The MPP gets activated during the solar process where there's full sun into the array. It gets shaded. That's when the VFD would create and allow the switchover into the main supply for emergency power, and then back to the VFD itself. So as you see here on the bottom, MPPT is disabled, obviously, when we go back to the main power source. So I think this is more helpful for those that are more visual as to how that looks like.
Yeah, basically, if the sun completely goes away, we switch to main power. And if the sun comes back strong, we can switch back to solar, which is great.
And that's the idea here. Yes.
Yep.
Another cool thing that we have with a small 320 compact VFD is having a pump curve in the VFD itself. Imagine being able to get a rough idea of the flow, the head, the power, how it's going to operate. And as long as we plug in that pump curve, we can actually create a flow estimation based off of that. So we add our 5 points from the pump curve, program them onto the VFD, and it'll create a reasonably accurate flow estimation of what the pump is there. This completely eliminates the need for a flow meter. But if you somehow do need to be very precise, the VFD can read a pulse counter and be very precise into how much water we're flowing, and even use that for invoicing or measuring purposes. So this is another way we can use a volume counter. A volume counter would either read from the VFD flow estimation or from the pulse counter and let you know how much daily or total volume flow you're getting based on the reset that you program onto the VFD. So going back to our very cool diagrams, this is what it looks like. the flow estimation on the bottom based off the VFD itself, and then the pulse counter, how to set that up, program, calibrate, and do our volume counter on the right, whether it's the daily counter or the reset counter with whatever we program onto there, monthly, yearly, and be able to record the flow. Anti-jam is also a very cool feature that we have onto the Altivar 320 Solar. It essentially will go forward or reverse if it senses a blockage on the impeller to be able to flush that rag or pollutant back into the system. Very important here that we put the minimum speed on forward and reverse that we can get from the pump manufacturer, and we have the instructions on the installation in user manual as well to make sure that we do that properly. This is really the best way to program this would be through our free software, the SoMove, where you can look at the graph, the forward, reverse, the acceleration, and program everything. You can also program through the dials or a RHMI, the VW3A111Y. Dry run prevention is also something we have in the VFD itself. So if there's a lot of air, there's not enough water, we also prevent the pump from running to make sure that we don't damage the motor. So this will help reduce downtime and make sure that the VFD and motor are protected for those circumstances. All right, so that's pretty much it for the features that we have available in the VFD itself. Heavily segmented towards pumps, ag, and irrigation. If you want to go here to some of the selection and sizing, we can definitely go through some of that. But before we run into this on how to size the VFDs in the solar, anything else you would like to add to the conversation here, Shawn, or any questions that you have from some of the stuff that we've gone through so far?
No, I think it's excellent. And I would ask the audience, what are your thoughts? Do you guys have applications where you might use this on? Could you get away with no batteries in your system? Would you do a tie-in to the line power? I'd love to hear what the audience is thinking at this point, guys. Feel free to, comment wherever you're listening or watching, comment on the show and let us know what your thoughts, because you guys are out there in the field doing this. I'm in here doing the interview with Nick, so I'm really curious to know what you guys are thinking. So, and let me toss it back to you, Nick.
Yeah, thanks again, Shawn. It's important to know that when you're working with Schneider, when we're working together with our distribution partners, we're here throughout the whole process. We have a solar sizer tool. We can do it through our simple Excel spreadsheet. Here is some data. We also have some very specific formulas to calculate the number of solar array panels. Also, if we have, let's say, not enough square footage on the farm or on the application itself, let's please keep in mind that there's different types of solar cells out there. There's the monolithic, there's the photovoltaic, and then I believe there's another one. But depending on the specific type of solar cell that you're using, that's going to change the amount of real estate and square footage that your solar array is going to land. So that's also important to note. We're going to help you throughout that selection process with the cut sheets. Make sure you have enough area. We have our experts to help panel everything top to bottom to make sure that this is a working application for our customers. And we finally got into this. I know we've touched quite a bit on this is going from the solar cell DC bus directly onto the VFD. Very clearly, no need for another solar inverter. You can actually put multiple solar VFDs on a solar array. And we have the specific instructions on how to do that. The protection fusing, the UL rating that we have on that. It is a PV SCCR, very unique to that industry. Again, very important, non-reversing diode blockage here for the solar cell for protection. The distances that you need to make sure that you have the right distance from the plus and the minus. And yeah, very important to make sure that you're putting the plus to the plus and the minus to the minus and not the other way around.
Yeah, I could see if you had a very large solar array, this kind of common bus topology would be so efficient, especially if you had multiple pumps, right? So having multiple drives all on that same bus with the solar panel makes a lot of sense.
Absolutely, yes. And frankly, I think this is just very unique, very innovative, and just thinking about working with many of you on putting some of these green solutions together that just get that useful power from the solar cell.
Now,
I just can't wait.
yeah, no, I noticed that the drives are interconnected with an analog
Mhm.
and daisy chained together. Is that for the MTTP so they know what everybody else is doing?
So yeah, we have a couple of different things that we can program there. We have the master slave function that we can use, and
Okay.
we also have a following function. So the
Okay.
PVSA here feature is essentially mentioning which pump to operate. So there's a couple of different things we can do
Okay.
depending on the need of the application. So it's essentially to make sure that our VFDs are communicating to each other, and especially if there's, let's say, a good way to think of it, a pressure sensor where you
Hmm.
have maybe the first VFD running at first level. If
Hmm.
the pressure sensor calls for demand, the first and second VFD turn on, and then the third VFD
Uh,
will turn off.
yep.
So there's
Yep.
many things that we can do there, connecting the
Got it.
VFDs with each other. Yes,
Nice.
and the ATV logic. So highly recommend that if you haven't looked at my previous podcast, we go into some detail as to how to do ATV logic, these function blocks, the Boolean, and how to do some simple applications. The goal here is that we do everything from the VFD itself. So all these arithmetic, please take advantage of that. If we do have time towards the end, Shawn, I do have a sample that I could share with the group here of what we did with some of the solar functions and the LED so that we can alert operators depending on how fast it's blinking, if it's in a specific function, if it's running, if it's stopping, or if it's at fault. So that's something that we did for the ATV logic for our customers here that want to use this for tanks, pumps, and irrigation.
Yeah, if anybody's listening, this is kind of like it looks like function blocks with like your standard gates inside a lot of the blocks. So it looks really cool. You get your inputs, you get your outputs, you got like where you can drop all the function blocks on the grid. And it looks very user friendly as well, how you're wiring everything together and, looping things around. So I think very intuitive for anybody out there who's done any type of function block programming.
And then going towards the end here, we still have our safety functions available like we do in our Altivar 320. We want to do this for machines, make sure we have necessary safeties when opening panels to turn the motor, the VFD, the pump off. We have that available as well. Safe torque off, safe stop one, SLS, the maximum speed, guard lock on the door. If you use the 312 solar, we do have some guidance here as to how to go from the 312 to the 320. Physical dimensions will be the same. IOs will have some minor differences. And we have the old versus the new model number as well. The other thing I would recommend, Shawn, and this is really towards the end of the presentation, just we're approaching the final slide here. The getting started with Altivar Solar ATV320. That's another useful video I recommend for those that have the VFD on hand. They want to figure out how to go through some of our parameters, program via SOMove, how to put the motor nameplate onto the VFD. This is a good getting started instruction YouTube video that we have for our audience here as well.
Let me ask you a question about SoMove. I think you said it was free, correct?
Oh, absolutely, yes.
So what do I need to connect my laptop to the drive? Because using the front of the drive is that's great and all, but if there's a free software tool, I think I would prefer to use that. But as far as connectivity, right? Is there a cable I need to buy from Schneider to go from laptop to the drive?
Yes, there is. And that cable really, Shawn, is there for those that require admin rights to connect onto other devices. So it helps
Okay.
bypass some of that, correct, and connect with the VFD. But you could really use just standard Ethernet CAT cable to go onto the VFD and straight from your computer as well, as long as you have the right admin rights there. You can do that as well. So move via the network. There's just so many ways that we can go into
Okay.
the computer and the VFD, but I highly recommend simple applications. You have your programmer right in front of the VFD to use our specific cable, and happy to
Mhm.
add what that model is. If you Google SOMove cable, it is a long model number. Okay, and that is pretty much it, Shawn. I really appreciate you having me. We can go through some final questions, and I'm just tremendously excited to work on some of these unique applications with our audience, our customers, and do something different in the industry out there. I think this is going to save a lot of headaches with remote applications. There's just so many ideas here for energy savings, portable machines, you name it. I think there's just a lot we can cover with this.
Yeah, too. And if you're trying to cut your electric bill down and you have solar, but you're like, this gives you a way to say, look, hey, if the sun is shining bright, we can run these drives off of the solar panels, and then hey, if the sun goes away, we can go back across the line and use power. But no, I just there's all kinds of great ideas. I can't wait to hear what our listeners have to say to chime in. I know a lot of them are driving right now or walking, but we love to hear you guys when you get back to wherever you are and where you can give us some feedback. And of course, you guys know how to find your local Schneider Electric, representative. They're all over the world. They're all over the place, just like all the major vendors are. But Nick, I'm excited to have you on. I think on the first podcast you've come on to talk about this. So thank you for not only coming back, but for choosing the Automation Podcast to be where you kind of debut the early launch of this. And just really appreciate you coming on.
Yeah, absolutely. We're very excited that we did our review here. This is really our pre-launch presentation, and yeah, many of your listeners, this will be the first time hearing of our ATV 320 pre-launch, and there's not a lot of 320 solar applications that have all these features and certifications on UL. So for those panel builders that were just waiting for that UL VFD that can do all this, it's it. We have it. It's out there.
That's awesome.
All right, Shawn. Really appreciate it. Very excited that we spent some time together, and encourage you or the audience to please do reach out, and happy to help you through this.
Well, I hope you enjoyed that episode, and I want to thank Nick for coming on the show and bringing us up to speed on the Altivar Solar ATV320. I thought that was a really cool product. I also think it was cool that Schneider sponsored this episode so we could bring it to you ad-free. So if you see your Schneider representative, please thank them for sponsoring their appearance on our show and underwriting the cost to edit it and put it all together and publish it. That said, if you'd like to get several of my hands-on videos that I do each week, Q&As, testing, hands-on, then you can join my membership program for just $2.50 a week or $10 a month on YouTube or at theautomationblog.com. It's a great way to get extra content as well as support my work in those areas, as well as if you know anybody who needs PLC, HMI, or SCADA training, please tell them all about my website, theautomationschool.com. I'm also doing in-person training as well. And with all of that said, I would just want to thank you again for tuning in. I want to thank you for being a listener or a viewer. And I just want to wish you all good health and happiness. And until next time, my friends, peace.